All right, let's take a look at getting this interpreter, resolver to work. So we've added this locals field to the interpreter, and now we have to handle how this expression evaluation is handled. So I think we can just give it the distance here. Oops. So when we evaluate an expression, we give it the environment to start from and the distance, the number of steps it has to go back. So let's get that working in here. Okay, evaluate takes an environment and it takes a distance, which is a usize. And let's try to format it so it looks a little bit nicer. So let's just remind ourselves. Okay, expression dot evaluate. Okay, so it can be any expression, but just so we keep up with the book, we can start here. And let's just give it as an argument to the get call. So we'll go in here and look at the get function, which also takes a distance, again a usize. Sure. So now we have to fix this. We have to say, okay, let's say let environment equals self. Maybe this is a bit weird way to do it, but bear with me, not range, it's not Python, come on. So from 0 to distance, we're going to reassign this to self.enclosing. However, this enclosing is optional. Yes, so we actually have to do something like this. If it's none, then we have a problem. If it's some, then we reassign, and that is it. And okay, so another problem is, so basically this should work. Value is self.value, not self, but rather environment.values.get name, and we can say it's okay or else, well, it's not an okay, right? So we can just do this. And that should work. However, the problem is what happens if the distance is not defined. So let me actually go back to the interpreter and see. So we say get distance, which is an option. So inside here, we should say it is an option. And finally in here, it's an option. And first of all, can we say if let distance none, no, sorry, if let none equals distance, that's how you do it. Then we will return whatever is in globals at this name. Otherwise we do this trick here. Now unfortunately we cannot quite check it because it will give us a ton of compile errors. And the first one is actually in here. And this one complains about this. Right, so maybe just unwrap here, just to keep the code like reasonably nice. How do we do this? Maybe we say sref. No, so we borrow it. Or can I just treat it as a reference somehow? Okay. Borrow. Do that. And right, because we have to return none. So we go on. Yet another value. This is, so we have to clone that again. Then we go in here, 319. Okay, this function takes two. What? Are the specials? Sorry, the interpreter. The specials is also an environment, which is a bit wrong. So I'm gonna change it to a hashmap. And hashmap. Let's try that. Okay, line 11. I'm missing one of these. Okay. So now because this is a hash map, we need to say the return type of it has changed, which is all well and good. Let me just check something. So it says define top level, which is a bit unnecessary. Let's say insert. Oh, it doesn't even exist. It's not only is it unnecessary, it's impossible. And we're just going through compiler errors, giving this new argument. Probably, I don't have to call cargo C every time, it's just like a nice way to do it. So it like clears up the message. Queue, whatever you want to call it, maybe it's not a queue. This one, just spot it, can add the argument there already. 423. This whole match statement probably should be taken out somewhere else. But whatever. That is not it. Line 20. Hashmap. And 59. It has an expression. Great. Why does it come? Ah, because this distance we should be able to move here. If I'm not, no, we cannot. We cannot. Go again. Complaints down here. But now it's the initializer. And then it's an 82. So three. $98. And this one shouldn't have changed, so I think we can just use the same again and again. Okay, right, so we have this thing again, just clone it so the values match, the types match, rather. And here we have to get the distance. And I think we are good to go. Why did I write value? That's the right distance. Now something in environment. Sure. Now we may not need that one. We do need that. We could do something else. We could make like a recursive thing. Okay, so if distance is equal to 0, we will get it out of this one. else we will look at the enclosing. And if it's none, we will return none. If it is, actually, here we should panic, I think. Try to resolve a variable that was defined deeper than the current, deeper than the current environment depth. Something like that. Otherwise, if it's some environment, then we will say environment.get name distance -1, and because of the typing, it has to be some. Let's see if that works. What is it saying now? Self to register get name. Okay, we have to clone it. We have to say cloned. Great. Get not found in. And of course we have to borrow this, and then we can call get. And now define top level is not needed. So we'll remove that and format it. Fortunately, it doesn't want to format any better than this. Okay, so now we can look up variables correctly. First we looked up resolve distance. Sure, we don't find. Okay, so he's here talking about the rest of the functions that we already implemented, like this get add, which is just our get function now. Which he has this implementation that I tried to do first, but we just used this recursive because it was easier. So let's go in and look at the assignment expression. Here it is. I think we already handled that. We also need this assign at now. Okay. That is very interesting. So anyway, we need the we already have the distance, but then we have to tell it to assign at that point. So we go in here to assign, and it will take a distance, which is once again an option of view size, and then we will basically copy the get function. So I'll do that off screen. So here we go. That should more or less do it. It's exactly the same pattern, except we're calling insert now. And it didn't like that so much. And we also have to return a value. Right. And with the old branches are just returning true now. Which is fine for now. What? Is it complete? Wrong place. Globals. So we have to borrow mutably. Ah, okay. So we can assign to globals. So we will just allow that. And then we have to fix this get globals, or rather this one. See if that works. And of course it doesn't, because here we have to say now that we borrow it. And there we go. So now we should be able to assign at a certain distance. Okay. Those are the only changes. Let's just verify that we don't need to make anything. I mean, we're okay, I guess. Come to think of it, maybe this function could take just self, so it takes ownership. That would be nice in those, in some cases where we like, at least in one case, this case, then we could just return the value back instead of cloning it. But again, that's for another time. Okay. Now we need to run the resolver. We insert the new parser after the parser does its magic. Let me check the main. So we have this run thing. Maybe it's the interpreter that should own the resolver, rather than the other way around. But let's just say resolver. We probably need to use it. Anyway, resolver, new, and the new function just makes an interpreter, but let's have it take one as an argument. Because then we might be able to do this. Actually, let me just try this. So now the resolver owns the interpreter. Then, what does he say? Resolve statements, which is fine. Resolver resolve, call it many. Maybe we should just call it resolve statements instead. Whatever. For now it's fine. Let's just see if it works. We unwrap and then we reclaim. Wonder if you can do that. We reclaim the interpreter. Probably it has to be public in that case. And it didn't work. Okay, one thing at a time. I really wish I didn't have to use a ref cell again, but I kind of think I do. It's just so easy to use ref cells, but if you use them everywhere, you're basically writing C# or something. Some garbage collected language. So where does it actually call the interpreter? It is down here, resolve local. And how would we do it? Well, it would still need a reference back, or it would need a function to call or something. So we can try to do that already. We can say, not that, but interpreter resolve. And like I want some kind of function, mutable function that has this type resolve local. So let me see here, resolve, or rather this type. So it needs to take an expr, return, rather an expr in the usize, and return a result. I think this is how you write it. I'm not sure how I want to refactor this. Let's just write resolve function. Is this thing. Can we do this resolve type? Is that? And then resolve type. Let's see how wrong this goes. Unused import. Don't care about that. This doesn't have a known type, so we can what can we do? We can add a box, or we can add, I think we can do like this. T solve type. Okay, I think that works. Looks horrible, but Looks absolutely horrible. But then down here, we should be able to say resolve function expert name unwrap and also self. There's another place which just calls resolve. My bad. It's not here. It is up here. And argument of type. What is it complaining about? It's getting an expression and a usize. Let's call it implementation. Because I used that name elsewhere, so implementation. And it says it's a field, but it implements that trait. Is it then like this where t equals? Saying what I should do. This way we get the field and then we call it. Okay, that kind of worked. So let's say resolve implementation is the interpreter dot resolve. And that likely doesn't work. Let me fix the other mistake it had, the other complaint it had. Okay. So it doesn't like this because resolve is a method. So I'm going to Google how to do this because I'm quite sure there's a way to do it. Okay, one thing I want to do is before this was a box of a statement, I want to change it to just a reference because that is also what this guy has, rect of references. So let's do that together. Then we don't need to call sref. And go to line resolve many statements. And now this, because the block, so we have to like map statement. It's a box, so let's call it B. See if that, well, it's not a vector anymore. So then we have to collect it, and let's see if that kind of works. It's not an iterator, so why don't we just iterate it, please? A value of type reference cannot, how about this then? Resolve function helper. Right, it's the same issue here, isn't it? This one takes now a vector of, so a little bit more annoying than you would think to mix all these things. 198. Same deal. And now it's just complaining about this thing out here in main. Okay. In the interest of time, here's what we're gonna do. Or rather, I'm not gonna do that because it's gonna be immensely annoying to look at. Instead, I'm going to do this. And then down here, we will call it like that. It's not nice, definitely not nice, but that is how it will be for now. Let's get rid of that. Let's get rid of that. Interpreter. Great. Down here, there's no longer that field. See how that works. Expected struct, but it found a reference. Right, because that is what we're getting in here. So maybe we just take ownership. Like why not? And that's not how you write it. Is it? So the parser, what does the parser return? It returns... this is so annoying. This is why we cannot take ownership. So it has to be a mutable reference, and as always, if we say that this is just a mutable reference, then it will complain a lot. And we have to add lifetimes, and let's just try it. Right, so this doesn't work because now this mutable borrow will overlap with this one. So of course that's not okay. And okay, now I've changed it so that it is wrapped inside an sref cell. I mean, the fact that I need this so many places is probably because I'm so used to working in like normal object-oriented garbage collector languages such as Python and C# and Java, whatever. And there's just something with the design that doesn't really work with Rust, or maybe it's just that there is no other way to do it. So if you have any ideas, please write them in the comments. Let me know what you think. But in any case, now it's running. So let me close these. We don't run the resolver if there's any parse errors. If the code is syntax error, it's never going to run. There's no value in resolving it. Yes, we already close here. Short circuit here. Tell the resolver to do its thing. At least that's true if the resolver succeeds. So I think it should more or less work now. Let's try to run the tests. And the tests failed. So let's environment variable. Okay. Tests, cases. I think it was that one, right? Yes. So let's open up a shell over here and say cargo run. Then we'll say a equals 2. That works. Attempted to subtract with overflow. Okay. That is great. Kind of. So I bet it's in here where it says distance -1. And really strange. Let's try to just assert distance is greater than 0. Not that, cargo run. So now I try to get the variable. Still, it's inside the resolver. If I just check carefully. So here's the problem. If the size is 0, then just return OK. Maybe. Again, don't do that. So a equals 2, print a. A has not been declared. Fantastic. So it's okay. Variable a has not been declared. Has not been. Where does it write that? Declared. Okay, it's inside expr. Has not been declared. So it's not in print, surely. It's here. Okay. Get So let's see what happens inside the environment when we call get. That is interesting. But what is the distance? Let's just print the distance. So we exit, cargo run, a equals 2. It is none. And it tries to go into globals. And it says it has not been defined. So let's go back into the resolver. It's calling resolve. Let me check that one. So is it ever defining into globals? Well, how do we actually define global? We have to call assign with a distance of none. We never do that either. We don't do it here. Wait. So let's go back into this one. Okay, so what happens when we assign it? What is the distance here? Let's write distance in assign. Okay. Never goes there. That's great. If statement var. So it's in here, right? Okay, so this also has to be supplied here to the define method. So let's go back to the environment. So we have, yeah, of course, if we have it in assignments, probably we also need it here. Okay. Let's try this. May not compile, let's see. Okay. We have to borrow mutably, of course. We have to go into Expert 310. That's interesting. What do we do here? Guess we just define them like immediately where we are. So we give a 0. Give a 0. And interpreter 1, 2, 3. And actually the same here. And again. And what is this? It's the function statement. And the function should also be defined right where it is. And again. All right. Let's try it now. Okay, that's great. What happens if we say so it's still printing none, which I'm not sure it should, because we're defining it inside a block. So let's go check. And we are running the resolver, right? Just like to really check nothing is wrong. Resolving. Oops. What now? Variable mod has not been declared. Great. So we say fun mod a equals 3. And then it has some issue with that. Great. Let me try to debug this. Okay, so before I forget, here's some things that I've done. So first of all, I've reverted the define definition. I'm not sure it needs a distance, because it's like it should always define it right where we are. It's only if we assign that it could possibly refer to something else, but a define operation should always be right where we are. So here's the problem that I'm looking at right now. If we do this, it should not resolve, because A couldn't possibly define refer to anything, but it doesn't. I've made some debug statements, which is what it's printing, but it's not giving an error. It's not panicking, which it should do. So what happens is that it passes this function statement, then it goes and sees that it's a function with this body consisting of a single expression, a single expression statement, which it then tries to resolve. It will go in here and try to resolve the value that is the right hand side, but that's just a number, so that will automatically resolve. Actually, just for fun, we can try this. So that failed actually. That's interesting. But whatever the case is, this should also fail. But it's going into resolve local and it's seeing that there's no scope. And then it's like, oh yeah, that's fine. So I don't know. Maybe we should say, yeah, it's okay. We assume it's a global variable. But then we do this, and we call mod. So we still cannot call this thing. We still cannot call a function. But before we go too far, let's not forget to look at this error, which if the other thing works, this should also work. So resolve expression, it sees that it is a something. Variable expression maybe. Although I don't think so. Okay, yes, it goes in here. So if it's not empty and okay, so we can fix it like this. So let's say let value equal this thing, but where we say okay or else something, we will say name.lextheme not defined. But this is very interesting. Why did this fail? What did I just delete? How do you redo? Okay, anyway, so what is the length of the scopes when we get here? Not that, let's go in here, let's say cargo run. That's scopes. I have no idea why it prints 22. 1. That's great. But how about down here? Shouldn't it also be... It never goes... Well, it never goes in here now because we have this panic. But then it will say length of scope 1. And... That is very funky. Okay, let's fix it like this. If let's false equal this. then we throw an error. Right, it's not, it should be that. Okay. Now let's see if it's at least consistent. This one still works, this one also works. We still cannot call this one. Which is what we should now try to fix. Okay, so what happens? We get the mod statement, which should be an expression statement. So let's resolve expression. Let's go in here and it should be a call. So we'll just write like resolving call, and let's get rid of the other ones for now. So call. Okay, let's rerun it. So goes into resolving call, goes into so still a print or what? No. So I think it doesn't make it to there. It does make it to there. Mod has not been. So let me see what the callee is. Is mod, and how come it resolves? So where does it actually fail? Doesn't fail there. So it's resolving correctly. Let's assume it's resolving correctly. That means it's not here, it's here. Has not been declared. It's saying so what happens in the interpreter? We define it, so let's just do this, defining function name dot. I cannot do that. Okay, but it defined the function. So it means we are trying to I think this is the problem. The distance is gonna be none. And then when the expression tries to evaluate it, it's going into get in the environment. And get, if it sees none, it just tries to get it from the globals. But the globals is something else than there's two notions of globals, which is a little bit unfortunate. And why did we do that again? Get globals. Maybe we get rid of that again. And then we simply say values is, if you make a new environment, then the values are simply whatever should be in the globals, which makes sense. Or no, that doesn't make sense. That does not make sense. Okay. Because the globals, the environment rather, that can be defined, and it is defined in various places, like here we define a new environment, here we define a new environment, and well, maybe it's okay. Let's try it. So if you define a new environment, you get the globals in the values. And then, then we just do this. Let's see, it didn't work. Okay. Okay, we don't need it to be this. So what's happening now is just that globals is something that's defined in every single environment. Yeah. Starting to need an issue tracker, I think. So we'll try this again. A equals 2. And it worked. What happens when it tries to interpret a distance in a sign? Distance, no, print. Okay, so assign success. It tries to call assign and assign here does insert, and we have to say match that one with something, then it should be true. It means there was already something inside, otherwise it's false, because I actually want this to fail. Exactly. But we can do things like do that and then say a equals 1, then call, that should work, but it didn't work. That's maybe okay, because here it's using clone of the environment, which should just be like a pointer to it all, actually. And it's again an expression statement. So what happens when we go in here? Let's see. Eval name. Then we declare it, and then we try to call this thing. So it's saying it's evaluating A, which is correct. Then it's going in here. Let's try here in the environment. Let's say some value, and we will say, no, that. Let's say this. Updating value. Oops. Okay, so it is correctly, but what exactly? Is something I don't. So let me try something else just to check. So if I now do this, I then say a equals 2. Will that even work? It did not work either. Great. So it is something else. Okay, I think I see what the bug is now, because in environment, when we try to get the value, it's not that it should get from itself, it's that it should get from... damn, because then... No, that's okay. It's not that... But now that we remove the globals, we gotta say match self-enclosing with none, Then we can do that with some environment. Then we have to say borrow get name distance. Great, still nothing, but it still says distance none for this expression, which is correct. And then shouldn't it try to get it? So what happens in here? It says eval a distance I really should put this into a file. Eval a at none. That's great. It's also in a sign that the problem is okay. This is getting tired. Okay, if the distance is none, it should again traverse all the way to the root, at which point we will do all of that. And before that, we will call in assign name value distance. Let's format that. Of course, didn't format. Match none. There we go. Let me go in here and say not there, but here, test cases. And these are like tests that we can run directly. So let's call it a resolve bug. And it be equal to fun mod equals 1 print, or rather mod print a. And now if we go to the shell, and we can go up here into test cases and cargo run resolve bug. Great. And we have to borrow mutably. Okay, it finally worked. And let's test the one where it looks like that. That also works. So we have a couple of debug print statements here that I'm going to remove. That one is okay. Let's go to the interpreter. I think it had one too. Actually, it had, oh, that one should be there. And let's run it again, see if it's printing anything. Nothing except what it should print. So we finally made it work. Now it is time for test cases. So we'll call it resolve 1, and that should be this test. Call it, we'll print a, and let's do this, and expect it. It should give 2, resolve 2. Let me copy this because it's going to be somewhat similar. We'll actually just do what we just did. this one we will, what is happening? Weird. Okay. This one is going to be more interesting. So now we'll actually make the resolution code do some work. So we have a global variable named a. Then we define a function in a local scope that modifies a. And then we define a local variable a. We call mod. And we print a. Now this should print 10, because this variable should be resolved to refer to that and not this one. And then if we finally print a down here, we should get 2. So we expect to see 10 and 2. And let's close that one. Why not? We can run it here. And it failed. So let's open up the resolve plug again. Let's see what it says. Now it's complaining about this again. Great. Okay, so after like very long time, I finally tracked it down. And this way of hashing or saving the steps using the address is not good enough, because we are quite liberal in cloning things, which means the addresses are not really really stable. So let's try this. There we go. So here you can see it resolves the definition of the name of the function at this address, which ends in 616. But then later when it tries to get it out, it tries to get it from 424. So it means that the expression or something has been, but of course, because it's like a different, of course, because it is a different expression. So that this doesn't work at all. We need to find a better way to do it. Right, I mean, if we just look at this one. Here it's one expression, and here it's a different expression. So like clearly different things. Which like makes me wonder how he did it in the book. But anyway. No, I didn't want to switch. I want to switch this one. How can we do it then? No, actually, I take it back. I think I misunderstood something. Let me open this shell again. So here is a funny thing. It is never resolving, like it's never calling resolve on this. And that seems like a bug. So actually it's not the thing I just said, because I think that's correct after all. Okay, but we have a call. We say resolving call. I am not really sure. What the order here is. So quite weird. Why is it saying resolving call already here? That doesn't seem right. It should say it down here. And what happens if I remove this? It says resolving call, which is correct. It's saying it in such a weird order, everything. Like it does the A declaration here up here, and then it does this A declaration, then it resolves that call, then it resolves the expression, then it resolves actually I'm not sure what the hell it's doing. Can we? Yeah, okay, it is that. After all, I think now again. So I'm going to do a final thing, and then this is the end of this video. Okay, I've been working on this for way too long, but what I tried to do was just give up on this, like using the address as an ID, and instead I just added an ID to all of the variants of the expression. Now, it still doesn't work, because when it's resolving, you can see here it says 5. When it's resolving, it thinks the ID is 5, but when it's getting it, it thinks the ID is 6. And that is causing a bit of an issue. And I have no idea why, because I'm only setting the IDs in the parser. And so why does it change? Why does it change after the resolution is done? Doesn't make any sense. And why would there even be 2? So let me try something. But I'm getting very desperate. So we get a variable statement, that is correct. We get a block statement that has a function. The function statement, yeah, sure. Then we get token, lexeme, literal line number. Okay, perhaps we're still inside the function here. Then there's a variable statement, variable declaration statement. Then there is a expression statement, which is this thing, which has ID 6. So that is correct. What if I print, actually let me take this one up here as well. Print that as again and run this again. Didn't like that. Okay, so same thing, but now what happens down here? So let's see the expression. Where we do the function call, it still has the ID 6. But in the resolver, it, for some bizarre reason, it thinks the ID is 5. I just don't get it. What if we look in the call just one final time? It's gonna be some really stupid, annoying error in call resolve. So yeah, that's what I thought. So it's whether it's using the ID of the whole expression or the name of the function. And we're storing it by name, so that means in the interpreter, or like probably, no, I want to do it in the resolver. So we resolve the callee. I'm gonna try something. Let's say resolve expression, but maybe I just want to call it directly down into resolve local. Let's try that. So not that, self resolve local expression. There we go. And I didn't want that because it also needs the name, which is callee dot name. Probably that will not work because it doesn't have name field name. So I'm gonna say this. I'm gonna just go down here and now it's really match expert with this thing, and if that match doesn't work, then we match with call, which has an ID that we don't need. It has a name, which has to be it has a call. What is it called? Callee, which is a variable with another ID that we don't care about and a name that we do care about, and it has paren and arguments. And if it's that, then we simply call resolve local on the expert with this name, and anything else we do that. Expected comma, yes, you will get it. Still isn't compile. Expected struct box. I don't know. Callee with this. Still, it's not gonna work. It wants a reference. I will give you a reference. (183) doesn't use the callee right now. And 293. So how about we just call sref, try to pattern match on that. It worked, it built, and go here, we actually rename it like that, and it finally worked. Now we just do this. Do that. That one's okay. Interpreter, print. That one is okay. This one, go away. Okay. To do, try the trick with addresses. Again. Try to run it. There is still some stuff somewhere. Maybe in the in the resolver. And expression. Where is it coming from? Ah, I know where it's coming from. Environment. Oh my god, that was such a struggle. And now that some of the tests are failing, but I think that's for another video. At least we got this scoping to seemingly work, but we need to write a lot more tests. Okay, see you in the next video.